today we're going to be having a quick look at how to evaluate the limit as x approaches 0 of sine of x over x. Now this function is sometimes known as the sinc function or the sine cardinal. Now this is widely used in telecommunications, electronics, and digital signal processing, and a lot of Fourier transforms as well. So widely used function, and it's going to be really useful for us to be able to evaluate this as x approaches 0. So now there's two main ways that I'm going to show you how you can approach this problem today. So the first way that I'm going to show you today is using L'Hopital's rule. Now I'm definitely butchering the pronunciation of that, but either way, L'Hopital's rule is probably one of the first things that you will encounter when you start discussing this limit here. So what does L'Hopital's rule state? It states that when we're trying to look for a limit, and direct substitution would reveal an indeterminate result, so meaning that we get something like 0 over 0 or infinity over infinity, something like that, right? Then what we can actually do is we can evaluate this limit by taking the derivatives. So we'll take the derivative of the numerator and the derivative of the denominator, and then we will be able to evaluate. So I might write this out now as limit as x approaches 0, d of dx of sine x over d dx of x. And so now when we evaluate this, let's see what we get. We get limit as x approaches 0 of, well, the derivative of sine is cosine of x, and the derivative of x is simply 1. So now we have the limit as x approaches 0 of cos of x over 1. Let's sub that value of 0 in, and we'll end up with a 1. And so we end up with a 1 over 1, and therefore we can say that this limit approaches 1. Now, let's look at another method, and this is a less widely used method to tackle this problem. So let's look at using power series. Now, power series is something that you might not encounter typically in most high school classes. So this is either going to be one of the more advanced topics that you might cover towards the end of high school, or one of the first things that you'll cover when you start studying mathematics in university. It's nothing too complicated. Basically, power series just allows us to rewrite functions as some sort of polynomial. That's the way that we'll treat it for now. So what this means is we can actually rewrite sine of x as some polynomial, and it's actually going to be an infinite sum from n equals 0 to infinity of -1 to the power of n by x to the 2n plus 1 all over 2n plus 1 factorial. Now, this looks extraordinarily complicated for a lot of people. Now, when I start writing this out, this will look so much simpler. So when we do start evaluating this, we'll see that it's equal to x minus x cubed over 3 factorial plus x to the 5 over 5 factorial minus x to the 7 over 7 factorial plus ... so on and so forth, right? So this is going to be valid for all values of real x. Okay, so now let's quickly see how does this help us. So now if I substitute this value for sine x back into our original problem of sine x over x, let's see what we get. I can now write it out as x minus x cubed on 3 factorial plus x to the 5 over 5 factorial minus x to the 7 over 7 factorial, so on and so forth, all over x. And reminder, this is taking the limit as x approaches 0. So now if I wanted to quickly simplify this, what I can do is I can actually just start cancelling out the x terms. So that x cancels out with this one, leaving a 1. It cancels out the cube, we end up with a square. Cancels out the 5, we end up with a 4. Cancels out the 7, we end up with a 6. And so on and so forth. And it would just keep simplifying as long as you want to keep writing it. So now let's see. This is going to be able to be rewritten as the limit as x approaches 0 of 1 minus x squared over 3 factorial plus x to the 4 over 5 factorial minus x to the 6 over 7 factorial plus ... And so now what happens as x approaches 0? Well, 0 squared is 0, 0 to the 4 is 0, 0 to the 6 is 0. So everything here will disappear except for that 1 out the front. And that's it. So that's how we can evaluate the limit as x approaches 0 using two different methods. Firstly, L'Hopital's rule, and then the power series. And there we are. So the limit as x approaches 0 for sine of x on x is simply going to be equal to 1. And there we are.